Well, we already know the meaning of regression coefficient from simple linear regression case, right? So we know that b0, its intercept, it's what y equal to when all x variables are 0. And the slope b1, b2, b3, and so on, it's influence or effect of x variable on the response. So what happens to response if you change this particular x variable by 1? So that's what we call an effect. Okay. In this case, in this example, I will use 3 predictors, age, region, and sex, and I will try to predict income based on these 3 predictors. Let's see what we get. So this is the table with regression coefficients I got from R. So you can see this is the coefficients, the estimates, right? So in fact, this is B0, this is B1, this is B2, and this is B3, right? And then you can see that as in the simple linear regression, we also make this test. You remember that this test is for beta equal to 0. So for example, we got minus 3.07. But what if in reality, in the population, the intercept is 0? Do we have any contradiction between this value and this null hypothesis? No, you can see that the p-value is pretty large. So in fact, we don't know the intercept for the population. It can be 0. We don't have anything that contradicts with this null hypothesis. Now, this is effect from H. Again, can it be just random effect? Can the real effect from H be 0? Well, it cannot. So in this case, we're kind of sure because the p-value is very small. So it means it's very unlikely that we observe this effect just by chance. Of course, the real effect is different. It can be a bit larger, it can be a bit smaller. We can compute confidence interval to see that. But at least now we see that indeed this effect is significant. This effect is reproducible. We will likely to see this effect over and over again if we repeat this experiment. Similar here. So can we got this is effect from region, minus 36.6 thousand krona, euro per year, sorry. So again, if we assume that in fact region doesn't have an effect, so we assume that salaries, the average salaries in Scandinavian countries and Mediterranean countries are the same. How likely we can observe this value or even larger? Right. Very unlikely. The p-value is very small. But you can see that this is an effect from the sex, minus 175. You remember that minus 1 is for males and plus 1 for females. So it means that the difference between males and females is 2, right? So it means that the effect is actually minus 175 times 2, which is minus 350. So it means that in our sample, in our data set, females in average have by 350 euro per year less than males. So we observe an effect from sex, from the biological sex in this case. However, if we assume that the real effect is 0, our observation, minus 350 or minus 175, if we talk about regression coefficient, does not contradict with this null hypothesis. The p-value is relatively large, right? It's very large. So it means that we cannot reject null hypothesis here. So it means that we don't see evidence that sex, based on our data set, of course, that sex has any relationship or sex has any influence on the income. At least, again, based on this data set that we possess. Okay. So how to interpret this value? So now we can just make a summary, right? So this is the model we got. So when you know age of person, you multiply it to 805. When you know region of person, it's minus 1 and plus 1, you remember, right? You multiply it to minus 3616. And then if you know sex of person, also minus 1 and plus 1, you multiply it to minus 175. And then the income, it's a linear combination. So it's a weighted sum where all these are weights. Okay. Now, we know that becoming 1 year older adds 806 euro per year, right? So it means that persons who are by 1 year older than the other person, they have in average by 806 euro per year more in our data set, right? So these are all about our data set. Then in Scandinavian countries, people earn by 7,200 euro per year more. Again, why 7,300? Why not 36? Because you remember that the difference between Scandinavian and Mediterranean is 2, right? So region goes from minus 1 to plus 1. And the regression coefficient shows you the effect of this variable when it changes by 1, right? So in this case, we have to double it, and that's why it's 7,000. And second, males earn by 350 euro more in our data set at least, right? But this is not significant effect. So it means that we cannot claim that this effect is reproducible. So most probably we see this effect as a random effect, okay, by chance. Now, as I said, we can also compute confidence intervals, right? So in this case, you can see I computed 95% confidence interval. So we have a lower boundary here, upper boundary here. And then you can see intercept can be negative, can be positive. So not significant, right? So it can be likely 0. But age is consistently positive. So we observe effect from age in our dataset 805 euro per 1 year, right? But in fact, it can be anywhere between 720 and 890. We don't know for sure, but with 95% confidence for the whole population, this effect is reproducible and it's positive effect. Likewise, region, also we observe minus 3600, but in fact it can be larger, it can be smaller. That's the expectations of this effect in reality for the population. But if you look at the sex, you can see it can be negative, it can be positive. Again, we don't see any evidence that there is an effect. Maybe there is, we don't know it, but we don't have statistical evidence that sex influences the income of people based on our data set. Okay, so this is just the adjusted conclusions, right? So this is what we can say. This is the effect from the salary for the whole population. This is an effect from the region for the whole population. Again, you remember I double these numbers, right? And then if we talk about the population, we cannot estimate the effect of sex. We can say that there is no evidence that sex has any effect on income. Okay. And then I can actually visualize this information by making a regression coefficients plot. In this case, you can see that this is the real regression coefficient that we observe. In this case, it's B2, right? It's region. And this is the confidence interval. So this is 2.5, and this is 97.5% interval, right? So by doing that, you can see, for example, this crosses 0, so it's not significant. This has a very strict positive effect. This one has a smaller, this is negative effect, and this one has a smaller positive effect. However, smaller and larger is very difficult to assess here because we have different units, right? So region is just binary value between -1 and +1, and then income, it's a continuous value, right? So how we can compare these effects? In this case, we can't, because these effects are uncomparable. You can compare the value, but you cannot compare the meaning of this effect. Okay. How to solve this problem? How to make effect comparable, and how also to make your model a little bit more robust, how to make regression coefficients more interpretable. That's what we are going to talk about in the next video.